Hello, you're listening to Linguistically Aware, a spoken word program about the ways we use, understand, and think about language. I'm Dusan, and today I sat down with Mr. Lyndon Rey to talk about the speech recognition systems. Apart from being a good friend of mine, Lyndon is soon to be a linguist with a master's degree. His research revolves around speech perception and recognition, while in his work he uses models for analyzing speech recognition across different language varieties. That is why Lyndon is a perfect guest for our topic on speech recognition today. Before you tune into our conversation, it is essential to acknowledge that this is CJSW 90.9 broadcasting on the traditional territories of all the people who make their homes in the Treaty 7 of Southern Alberta.
I guess you could call me a computational linguist, though people don't necessarily have a good definition for that. Basically, what I do is academically, anyways, I focused on acoustics and phonetics, specifically perception, so sound, and using computers to model what was happening with speech perception specifically. So the short answer would be I work on making computers able to, or making models that are able to act the same way that humans do when we're understanding speech.
Yeah, that sounds great. We'll talk more about that. What's your job about? What are you doing currently?
Yeah. So my job title technically is research scientist, which is very vague, but basically what I'm doing is, so I'm working for a company that does, they make speech recognition software. So what they do is they build the whole process basically, so goes from me speaking or you speaking all the way through to understanding what we're trying to say. So, and whether that be looking at what somebody's intent is or specifically what words they're saying or whatever. So what I do, where I am in that pipeline is I'm working on building models that help predict what word is coming next given the context. So I don't work on the actual acoustic stuff right now. That is very much a software engineering and a mathematical sort of field. And my expertise is more in the actual languagey part of things. So basically the way any speech recognition system works is that there is basically a signal processing module that will take the acoustic input and then make hypotheses about what word somebody was trying to say. And it's really hard to guess just without knowing anything but what word was trying to be said, basically.
Yeah, I want to ask, why is that relevant? Why do you want a word to be guessed in your job?
Yeah. Well, yeah. So we need a word to be guessed because basically the whole point of the first half of speech recognition is to understand what words are being said. So you need a word to be guessed because the best guess becomes the output of the model. So what it's actually saying somebody is, or what it actually thinks somebody is saying. So a good example would be the words pert and Bert. I guess they're not really words, but they look exactly the same to a computer or very, very similar. And in a lot of languages, they actually are the same, or a lot of dialects. So something like that, maybe they'll mean something completely different in a language, but a computer can't tell them apart. Though, yeah, so what I do, or what the team that I work on does, is looks at a whole lot of text, basically, like on the billions of words sort of scale, so huge amounts of text, and then comes up with a bunch of different ways of modeling this text to understand or to help predict what word it should be. So we look at things like context. So if the solution is for a car, then it's very likely to have car related words versus those words normally wouldn't be said that often in a general context. But then most of what I do is actually looking at the preceding words in the sentence. So the hypothesis, or I guess the theory, and it's shown to work really well. And this is how basically every modern speech recognition system works, is that the acoustic recognizer comes up with a list of possibilities for every word, and then those possibilities are weighted based on their likelihood of actually occurring in a real language or in the real language that they're trying to predict. So
Yeah.
the simple way to describe it is like, if I have a sentence that says that car is, so let's say I say that car is, and then something, and then the system is trying to, or the recognizing system is trying to come up with what that is. It's very much more likely for me to say something like blue versus something like imbue, like the verb to imbue, even though those are really similar and would look very basically the same in a speech recognition system. It is almost certainly blue, given that
Yeah.
works contextually. So it's using the theory. Is
So you're
that
basically eliminating the potential candidates. Yeah.
yeah, and that's how it becomes accurate. Like no speech recognition system can just use acoustics to be able to predict what word somebody is saying. They need to know more.
Of
And that's
course.
why even like I noticed this a couple days ago actually on Android, on Google speech recognition system. You'll sometimes start saying something and it'll have a completely different prediction until you say 4 or 5 words and it'll switch to what you actually want. And that's because it's using the
Yeah.
like it's using the context, the words that you're saying, in the sense that it could be anything or it could be a bunch of different guesses, but after you say enough words, it's like, well, we're 90% sure it's these words, so it means that these words that we're not sure about, we can guess those as well. So
Yeah.
as I said, yeah, so long-winded answer, but basically what I do is build models that predict what a word could be or what it probably will be given what we know.
Excellent. Yeah, that sounds really interesting. And before we move on to that part of the discussion or conversation, I want to ask you, how did you decide for this job? What made you apply for this job specifically?
Yeah. So it's not, I kind of already had this job in my crosshairs for a little while because so I worked at the same company in 2018 as an intern. Um, and that is something that helped me immensely in getting this job because I was able to talk to my old manager and he was able to refer me. So that helps.
Yeah.
But also when I worked at this company, I was working on the services side of the company. So I was working directly with clients and helping them tune these speech recognition systems for their specific uses. And now I enjoyed the work, but I always wanted to do something a little bit more researchy or research and development. So I basically, when I went to do my master's, it was with the explicit goal that I wanted to go back to this company or a company similar to it and then do research and development. So that's where I am now. So when I was getting close to graduating, I started reaching out to people. I started applying to jobs at this company and other companies as well on the research side of things. And so that's how I kind of targeted this specific position, was because I knew it existed because I'd worked at the company in the past, and I don't want to say I targeted my master's degree towards this, but it was always in the back of my head when I was choosing what I did during my MA.
Yeah, that sounds great. Why not? Why not?
Yep.
Go along this path. What kind of linguistic knowledge do you need for this job? You've said that you had you're going to have actually your defense very soon of your MA thesis. So what kind of linguistic knowledge did you want to acquire in order to be able to do this job very well, or just to be at this job?
Yeah, so that's a really good question. I actually was asked this in a bunch of interviews at other companies. They were saying, you have a linguistics degree. Why do you think you can work in a job that is the majority of this job is statistics and modeling and computer science? And it took me a few tries before I actually had a good answer to that. But basically, I would say that there are very few specific concepts or facts that I learned during my MA that are actually useful in my day to day. And that sounds strange, but the thing that I learned most in my MA was the ability to read linguistics research and linguistics literature, and then be able to take that and apply it to a business computational setting. So an example of that is, so right now I'm working on a project involving, I think it's Polish or
Mm-hmm.
Polish, and then I'm going to be working on another project involving another language, I think Russian, something with cases anyways. So the
Okay.
nouns are inflected.
Yeah.
And I don't speak
Slavic.
Polish. Yeah, I don't speak Polish. I know nothing about Polish, but I was told, oh, look at this data, figure out what's going on here, and then improve our model.
Yeah.
So what was going on is that in this data, people were saying uh, sort of more technical things. So it was in a TV context. People were saying more technical things in English, like HDMI. But then they were inflecting these English nouns in Polish based on where they appeared in the sentence. So if it was an object, they'd inflect it differently. Or, as I said, I don't know Polish cases, but I assume that's what was going on. And then, so that sort of concept, even just having familiarity with that was able,
Yeah.
saved me a week of trying to figure out a pattern here. But then also just more generally, it helps me look at a problem, because every problem is still based on language. It's always about a language.
Yeah.
So when I get a project that's based on language X, what I do is I look up this specific part of language X, and even just having the ability to go through, very basic linguistic resources quickly and understand what they're saying is hugely useful. And it helps me, get a good sense of the project, but it also helps me kind of contextualize where the project fits in the overall solution. Because, as I said, it's still language, it's still people talking. And no matter how technical something is, you can't forget about the fact that it is people talking and people need to understand, right? So that's that's where my linguistics knowledge comes in most, is just the ability to take linguistic data or linguistic research and just make it actually useful for a computer program.
Yeah, that's a good response, I guess, and I would agree. It's that we're trained in recognizing the patterns.
Yeah.
The language patterns that some people or other people who work in programming, for example, would not recognize. And that's very useful for your job, I guess.
Absolutely. And then even just, in grad school, we all know everybody reads a bajillion papers, right? So you get very good at communication, very good at reading a paper, and maybe not reading it cover to cover, reading every single word, but being able to pick out the important points. And that's hugely useful, as well as being able to go the other way and take a computational system or a computational solution and then put it back in terms of the human component, because that is super useful, especially in a business setting where a lot of people don't necessarily care about how things work technically, as long as they work and they make money, right? Because that's why we're making software, right? It's to help people, but also, you got to make a profit, right? So if you can easily communicate what a project does without getting too technical and still make it seem or relate it back to the fact that it is for humans to use, then it helps you out. It makes everything more clear to everybody.
Hello, you have tuned in to CJSW 90.9 FM radio station. I'm Dusan, and I'm talking to Lyndon Rey about speech recognition systems. You mentioned a couple of interesting things I would like to go back to.
Sure.
The first is that you are doing something on Polish language, let's say. You want to recognize the patterns of this language. I've also tried a couple of times as a non-native speaker of English, let's say. I'm not a native speaker of English. I've also tried a couple of times Google Assistant and Google voice recognition, and it recognized my accent pretty well, but there were many mistakes. I mean, it misheard me many times because I guess it's picking out the signal, and also doing some algorithms probably that would give it some word that is probably useful in that context, but it's not the words that I produced. How can you make it more efficient? What can we do to model this speech?
Yeah.
That is
So,
for
so the short answer to that is that if I had a good answer, I would be a billionaire. That's a
I
huge
know.
problem in the industry, and it makes sense. Is that especially with you know, a whole lot of internationalization happening in the past little while, kind of concurrently with these sort of technologies, that you can't just assume that a technology deployed in a country, everybody will be a native speaker that's using it, because that's not a good assumption. Like, obviously, that's a super naive assumption. So it's a big problem, and it stems from basically building models that are only trained using native speaker data. And that's unavoidable at the beginning, because the more consistent data is, the easier it is to build a model. So when you're building a base model, then you generally will only use consistent data, because it makes it easier just to get any results. And a model that works poorly is better than no model at all most of the time. Though it's a really good question, and there's not really a good answer what can be done. In a perfect world, you would be able to select your first language, and then there would be a separate model for for Serbian accented English, and then it would be and then we'll get everybody that speaks Serbian as a first language and then English as a second language to record a whole bunch of text, and then you build a model based on that. Though that obviously isn't practical. And then the more unique the combination gets, then the tougher it is and the less economical it is, right? So, there are certainly, and I can't speak to this directly because I don't work specifically in this right now, but there are certainly models that are for, English accented with another major language. So, I think especially in the States, there's a whole lot of people that speak Spanish as a first language and then speak English as a second language. So there are certainly models that work for that. But then the other thing is that Spanish is a huge language as well. So it's just easier to have a Spanish model. It's in case like yours, where you have where I don't know how robust the Serbian speech recognition modeling, field is. And I doubt it's very robust because there's just not a lot of Serbian speakers relative to English speakers or French speakers, for example. So the next, I guess, solution would be to, and it's starting to become more and more common, I think, and this is just speculation based on what I've heard and seen, but models that are tuned to individual people. And even back as far as, in the early 2010s sort of, I remember I was in high school screwing around with speech recognition software on my computer, and actually made by the company that I work for now, just back in the day. And basically the first step, you had to spend an hour and a half reading a whole bunch of text, because then it tuned itself to your voice. And that's another way to do things, but that's not super practical anymore, especially for mobile applications, because people just don't want to do that. So another solution is to use people's actual voice and then have some way of tuning a model to match that. Though that's not always practical, because sometimes, or to do that, you need to know the right answer, for lack of a better term. So sometimes, like in the software setting, I can sit down and read a bunch of stuff, but I know what I'm reading, or the computer knows what I'm reading, and it knows what to match up to what word. Whereas in a situation where I buy an Android phone or an iPhone and I want it to work right out of the box, then you can't have that, or it's not practical to do. So yeah, it's an interesting question. As I said, the perfect answer is that you build a model for every possible combination, or at least every possible family, I guess, but in the end, it comes down to trying to support people's native language first and foremost, versus a second language, I think. And in a perfect world, we could just take data from every single language and build a model, but that's a long way off.
Yeah. We're not there yet. And
No.
I doubt we will be. That's a huge issue in speech perception, variability
Yeah.
of each
Yeah. Well, that's the thing with
individual.
especially with a second language speaker as well. People are at different levels or have different accents, right? So
Yeah.
even for somebody that's two people that speak the same language natively and then English as a second language, they might sound different.
Hello, you have tuned in to CJSW 90.9 FM radio station. I'm Dusan and I'm talking to Lyndon Rey about speech recognition systems. I am curious to know what programs are you using
Yeah.
currently, maybe, if you're allowed to say, or what programs have you been using
Yeah, for
for
sure.
speech recognition and the learning
Yeah.
language, programs.
Yeah. So like any good linguist, I use Pratt a fair amount in order to look at spectrograms because that is basically what the computer is getting. So to be able to
Prat
see
is
that
like
a
PRAAT. Yeah.
AAT, yeah, that is, and sorry, I should clarify that's an open source piece of software written by two Dutch researchers. I
Yeah.
don't remember what university they're at, but basically they have done a huge service to linguists all over the world by writing this incredibly good piece of software that lets you analyze speech. So I use that a fair amount. But then as far as modeling goes, I use a Python package, or I not Python specifically, I guess, but a library called TensorFlow, which is relatively commonly used nowadays.
Mhm.
And it builds fancy neural networks, and it means that I don't have to do a lot of the like software engineering because I'm not a software engineer. I'm not going to be able to build anything half as good as these people. And it was started by Google, so they had a lot of money and a lot of skill, a lot of talent behind it. So it's always going to be better than what I can do. So with that, it gives me a framework to be able to build model. And I still have to have good data. I still have to set up the model correctly, but I don't have to build the actual moving pieces.
Yeah, but you have this useful skill. You know how to use the
Yeah.
program, and yeah,
Yeah.
that's more than enough, I guess.
Yeah.
Um, uh,
And then just,
huh?
sorry, I should clarify, as far as, programming goes, people ask me relatively often how much programming I do day to day. And it's honestly not much, but it is enough to be able to do things automatically, I think is the
Mhm.
biggest reason I use programming. Because most of the stuff I do, I can do by hand. So for example, data cleaning, you have a bunch of text and you want to take out all the punctuation, or you want to take out all the words that aren't in a certain list of other words in a dictionary or something like that. I could do that by hand. It would
But
just take me a long time. Or I can spend 15 minutes and write a small Python program that will then do that for me. So that's what I use Python for day to day. Is nothing super fancy or anything wild. It's very much just saving me time and keystrokes.
yeah, with respect to the modeling, another big picture question:
Yep.
can we model the specific part of a language? Let's say, um, how, for example, we want to build a model or develop a model
Yep.
that can emulate some sort of perception or
Yep.
production of some part of speech.
Yeah, so I can answer that from a perception side because that's what I did my thesis on.
Mhm.
Production is completely different. I don't actually have a lot of experience in modeling speech production, but I can talk about the perception side of things. And basically, um, yes, to an extent, it can be modeled. So the thing that is the most important here is that it is actually, people don't act rationally very often.
Mhm.
Well, mostly often, but
Mhm.
people don't, and especially person to person, they don't perceive the same stimulus the same way, right? So building models to predict that is hugely difficult because unless you had an actual copy of every single thing about a person, you couldn't necessarily tune your model or use that as an input into your model to be able to better predict this. So like an example from my master's thesis is that, so I was looking at the perception of honesty. So what makes some speech sound more honest than other speech? Not whether it doesn't matter if it's actually true or not. I'm not trying to pick up lies. I was trying to model, why do people, think some speech sounds less honest than other speech. So I had lots of examples where when played a pair of sentences, one person would say, oh, this one's more honest. And then another person would say, that one's more honest. They heard the same thing, but they just disagreed because they were different people with different experiences, right? So, and that's something that is unavoidable. So it'd be impossible to build a model that works all the time, even if it's something as simple as what word somebody said, or what phoneme, what sound somebody or what letter somebody tried to say, or how they perceived it. You can't predict what somebody's going to perceive all the time.
I want to know, what do you think about the AI models?
I tend to be pretty pessimistic about the limits of AI as they stand right now, because having been on the inside of building AI models, it's really easy to hype up an AI model, but it's really hard to make an AI model that lives up to the hype. Especially in media, everybody wants something that can learn and act like a human, or most people do anyways, but that's not very practical, but it's fun to write articles about it, right? So
of course,
in this context, yes, they can learn as long as there's a feedback mechanism. So nothing can learn, or it's hard to make something that learns without knowing if it was right or wrong, right? Or how well it did. It's the sort of thing, actually, like that's how a speech recognition model works, right? Is if I read a bunch of sentences and then I build a model trained to identify speech, I am basing the model that I trained off, or I'm basing the model that I trained. It's based off of what it knows about what I just gave it as its training data. So it knows that when I say the word cat, it looks like the spectrum, it looks like the acoustic breakdown for the word cat. So it knows if it's right or not. And then the way a model gets better is that it gets fed more right or wrong data. In a social context, it's really interesting because you don't know whether it's right or wrong or not without an actual person telling you. And I think that's one of the biggest limitations on chatbots right now. For example, something, when you go to a website, it'll say, what is this? Or what do you
usually
want to do?
With, for example, telephone companies or internet companies that they have chat box. Then you insert then you start to go around them by inserting just the word agent, for example, or customer service, and they recognize that. If you have a full sentence, then they might be misleading you.
Yeah, exactly. Yeah. So, and that's the sort of thing where it's hard to know whether it's completely right or not, because it's not human. It doesn't know. It's just looking for intent, basically. See, it says, what do you want to do? Or what do you want to talk about? And I say, I want to change my password. It hopefully has seen enough variations of, I want to change my password, that it knows 100% are about changing password to be able to predict anything that it comes in. But then let's say you have a completely unknown construction coming, you have Yoda from Star Wars come in and say, password, I'd like to change, or something like that. Then that's hard, even though it seems completely easy. Like, we look at that, we're like, of course the person wants to change their password. That's why we can understand Yoda when he speaks. But a computer, if they haven't seen that or experienced that yet, then how are they going to know, right? So that's so that's the hardest part, is just capturing the variability in how people act in the model, because it's impossible to ever have a training set of data that is complete regarding how people act, right? So and people are starting to get around that by using sort of fuzzy algorithms that say, okay, well, this is probably this, even though we can't say for sure. But it's still never going to be perfect. And that's what people are really good at, is picking out what somebody's trying to say from a whole lot of meaningless stuff. We're never going to have AI that you see in the movies and stuff like that, right? You're never going to have like Matrix level AI.
Yeah, I hope.
Which is
not.
probably a good thing,
It's a good thing.
That probably wasn't the best example, but
but
it's like that. Have you ever seen that movie Her? It's about
Yeah,
this guy that falls in love with his smartphone. I don't think that's going to happen anytime soon. I hope not, but
yeah,
at
not
least that was a
anytime
little
soon.
bit more benevolent than The Matrix. But I
That
gotta
one
watch
is
The
a bit
Matrix.
more realistic
Yeah.
for the time being. Yeah. Thank you for talking to me about this cool stuff.
Yeah, no worries. Thanks, Dusan. That was really, I always like talking about it. So thanks for the opportunity.
That was Lyndon Rey, who explained how speech recognition works and how he uses speech recognition software in his job. You can reach out to Lyndon through his website, lyndonrey.ca. Lyndon is spelled with a Y. Listen to the upcoming monthly episodes of Linguistically Aware on CJSW 90.9 FM by visiting the CJSW program Linguistically Aware. My name is Dusan Nikolic, and I am the host of this wonderful podcast. If you want to contact me, visit dusannikolic.com. Dusan Nikolic. Have a great day and stay with CJSW.